What's up, everybody? Steven, the Lightspeed here, and today we're going to talk about the Mosquito hotend. First things first, this video is sponsored by Project R3D. Project R3D was nice enough to send me some warranty parts to repair this hotend. When I bought my rail core, it came with this with a Magnum that was encased in plastic and had some issues, and R3D was nice enough to send me the replacement parts to fix it. At the time, the current model was the V1 of the Mosquito hotend. Today there is a V2, which we'll talk about a little bit later. But first, I want to kind of go over why is this hotend so special? Why is it so expensive? And should you buy one? Should you not buy one? I don't know. And we're going to talk a little bit about some of the things that I think that make this hotend special. So with that, let's get into it. All right, so first things first. What makes this hotend special is this hotend was developed by Slice Engineering in Florida, and it is an American-based company that manufactures these in America. It's not just designed here, it's actually produced here in the United States of America, which is pretty awesome. But my understanding is they developed this hotend to work in a high temp environment, and that's mainly the purpose of this. So you might be wondering, like, well, why do you see these on so many printers? Well, you know, they're not printing Peak or Ultim or, you know, PEI or whatever else you can print at high temperatures. Some people are using them for that, for high temp environments, but I think by and large most people are using these because they're compact, they're rigid, they're made in America, which is, you know, most Americans like anyways, and you know, they're reliable. They just work. One of the nice things about these hotends is they just work. And it kind of takes out some of the human error that can occur when you're using like a V6. You know, these V6s, you have to know how to seat the nozzle against the heat break. You can hit things and break it, bend it, and start causing problems. If you don't have proper cooling on a V6, you will have big problems. These will have what's known as heat creep, where the heat from the block basically soaks up the metal all the way to the top. And then you're making molten plastic at the top of this instead of where it's supposed to be down here by the nozzle. You know, that's a really common problem with these is cooling is a challenge. With this design, the heat break, which is the thing you're concerned about getting heat creep, is predominantly stainless steel tubing. And I mean thin surgical stainless steel tubing that is very sensitive. So, but one of the nice things about this tubing is that, you know, in general, as long as there's a decent fan on it, and I mean, you know, it just needs a little bit of air that goes on right here. This heat creep on a Mosquito hotend is pretty much not really a thing. Now, it can happen, and it does happen when things get dirty or the fan's not working properly or whatever, but in general, it's not really a thing. So, what happens though when people do have heat creep, or what they call heat creep, is it's usually when they do a big retraction or an unload, and the filament will come out the top and it's still a little soft, and it will get stuck right here in this little ridge. And this is designed to have a PTFE tubing seated in it, and if that PTFE tubing is not seated properly, you can easily get a little glob right there that you cannot get out no matter what you do unless you take it apart. A lot of people take tools like this and they stick it in here and they start, you know, I've seen people banging on it with hammers. And like I said, this tubing is very thin, and if you're not careful, you will bend it, break it, dent it, whatever. Once this tube is dented, it's over with. You got to replace it because the tolerances are so tight in here that filament will not pass through it. So just be warned, if you have a jam, you're better off taking it apart. Let's face it, these are not cheap, and so, you know, why risk it? Take it apart, put some heat on it, and start cleaning it out the right way. So, but anyways, so that's basically what the Mosquito is a small, compact, robust, you know, hotend that is designed for high temp environments. Now, people like me and most people are using them because of their reliability factor and the fact that you can have a whole host in your ecosystem of Slice products that will allow you to do nozzle swaps. Now, yeah, you can change the nozzle on this. Trust me, lots of problems start from a nozzle swap on a V6. People get Prusas all the time. they sometimes don't come assembled properly, and they'll start leaking. But a new user will change a hot end on this, and they'll go, oh, I need to tighten it, right? So they'll heat it up to 270 degrees, and they'll start cranking on it, and they'll click, you know, and you will strip these blocks extremely fast. These aluminum blocks are soft, and when they're hot, they're like super soft. So stripping blocks, big problem. You got a, you know, steel or brass nozzle going into a soft aluminum block, it strips like crazy. Or you don't get it seated against the heat break right. You know, those things happen all the time. And just in general, I've seen a lot of people have challenges with this. It doesn't mean you're dumb. It doesn't mean anything. It just means, you know, there's a lot of issues. These are pretty difficult to understand what you need to do when you first start doing nozzle swaps, or if you hit something and bend the heat break and you're changing heat breaks. You know, yeah, this is the tried and true design. This design's been around for a really long time. E3D has sold probably tens of, you know, hundreds of thousands of these things between theirs and the clones, and they work good for 99.99% of people. But if you want something better, meaning more reliable, and by reliable I mean, you know, they're just less likely to have a jam, less likely to have an issue, that's where these guys come in. So, you know, I've been very fortunate in my life, and I have these on every printer I have, because I like being able to do quick nozzle swaps with one hand. I don't know if I mentioned that, but the way these are mounted, you can do nozzle swaps with one hand. You don't have to get the pliers up there and start, you know, screwing around with it. You can do one-handed nozzle swaps with this. So that's one reason I like it. The other reason is I like that from a thermal standpoint, they're very, very stable. These copper alloy blocks are extremely robust, and my experience with these is using the Slice heater and the Slice thermistor, and, you know, along with the Slice hot end is, you know, after doing a PID tune on your printer to tune your thermistors and your heaters, these hot ends work flawlessly. So yeah, so that's pretty much why you would want one of these. You know, I use them for reliability. I use them for the one-handed nozzle changes, and, you know, if I ever want to do high-tech printing, I can, because I already have the hot end. So that's another thing, is upgradability in the future. But the main reason is because I like the way that you can rebuild these. So, you know, yeah, you can rebuild a V6. I'm not saying you can't. You can, I mean, absolutely do that. But a lot of people spend the money on these or look at these and go, why would I spend so much money? You know, what if this happens? What if that happens? Well, these hot ends are fully rebuildable. You can absolutely rebuild these hot ends, and we're going to look at that today. First and foremost, we are going to look at the rebuild process of a Magnum, a V2 Magnum. So, you know, for me, that's the nice thing, is I got a couple spare parts laying around. If I do screw something up and I break the heat break by jamming this into it, you know, I can take it apart and pretty easily put it back together again. So, but anyways, I am a big supporter of US companies. I think Slice is a great company, and yeah, so, you know, I prefer them. I would rather spend the money on this than go, you know, having a bunch of E3D V6s to go and work on. So, at any rate, this video is about taking this fantastic, amazing hot end and rebuilding it into the version 2 Magnum, and showing you how to properly put it back together. I have a lot of experience with this. I've done many of these rebuilds, both for myself, and I've done a few for other people. You know, and once you get this set up, as long as you don't do something stupid, this thing, you know, as long as you don't do that, you're generally in pretty good shape with this. You know, again, it will give you many hundreds and thousands of hours of fantastic print quality, reliability, etc. So anyways, thanks for watching. Let's get on to the video. See you at the end of it. All right, so we're gonna reassemble a Magnum or a Slice hot end. I've already taken this one apart. This one, nothing was wrong with this one. I'm updating this one from the V1 Magnum. This guy right here. So this is the V1, and I'm upgrading it to a V2. There's some noticeable differences here. there is an outer sleeve over this surgical tube. It's heavier for sure. And other than that, I think it's relatively similar, but at any rate, we are going to take a V1 block and we're going to put a V2 heat break. You also need to put a V2 heat sink on this hot end, as the V1 hot ends here, or the heat sink here for the V1 will no longer work. So these are unique to the V1 Magnums or Mosquitoes. So the first thing you want to do, I've never seen anybody say to do this, but that I've assembled about 10 of these, and I always put a little thermal paste on this. I think it just makes it a little easier getting it back out. So we're gonna go ahead and thread. Okay, so now we have the heat break threaded in here. Again, not a lot of instruction on how to assemble these, but I typically take a pair of pliers, I heat the block up with a heat gun just a little bit, and then I grab it right around here, and I just give it a little snug, a little tug right there. You don't want to go crazy, you don't want to over tighten this, because the one great thing about these hot ends is you can rebuild them. Now they do last forever in their stock configuration as long as nothing bad happens. But if you ever want to rebuild it, you definitely don't want that stuck in there. Probably the biggest challenge to this rebuild are these little pins. These are the same material that the heat break's made out of. And you can see when they come out, they're never clean, right? Because they have filament and whatever on there. So it's worth your time to clean these up. Now, you can go and purchase one of these, a hot block kit, and these are very, very nice. This makes the reassembly a lot easier. And that's probably what I'm going to use on this. I will save these for if I ever have another problem. But I typically go and I clean out all the holes as best I can. I usually wire brush the block. I didn't in this case because this block is not that bad. But once this heat break is on here, then we can start adding the little surgical standoff tubes, which by the way is what allows you to have one-handed nozzle changes. So that's nice. And then we are going to put in the heater, we're going to put in the thermistor. In both cases we are going to use the Slice Engineering, this boron nitride thermal paste, and to make sure that we have good contact between the both. All right, next step here is once that's on there, we're going to put this on. Now I'm reusing this one. There's nothing wrong with reusing these. These are very, very, very fragile. So you do not want to be trying to tighten this through this or whatever. Put this on last once you got this tight. Now, I have in some cases, I put thermal paste in there to kind of better have a thermal connection with the melt zone or of the heat break here. But in this case, I'm not going to do that. And the reason is every time I do that, when I go to rebuild one of these, I cannot get it off of there. By the way, this was supplied by Project R3D, the guys that make the rail core. He also supplied this. I should say this also, but you want to make sure that this is tight before you put these pins in. Once these pins are in, you will no longer be able to tighten the seat brake. So just a little tip for you to make sure you tighten this down again with the pliers and just snug it down. Don't go crazy because it is copper and it will mar pretty easy, which is fine. If there's a little marring on it, it's not a problem, but you just want to generally be kind of careful with it. All right, now we got the little standoffs in there. Sometimes these don't go in well, especially when you're rebuilding a block. It definitely doesn't go in well. I take a drill bit and clean this out. I heat the block up with a heat gun, and then I run a drill bit down inside of there. That's the right diameter for this. Now, I don't have one that's perfect. It's just a little too small, which is fine, but just to kind of get any of the gunk out of there, because these do build up gunk inside of here. So Anyways, next step is to put the heat sink on there, and again, this is the old one, and I suspect the differences are, we'll look at them here in a second, but I suspect that the difference here is the little opening right there. You can see this is a fatter, this is a way bigger opening than this one has, you know. So this one would sit sits inside of here like this. You see that it's right there. So I suspect that this one being bigger would not fit in this heat sink. So I had to buy the new heat sink to go with it. Yeah, and just as I suspected there, you can definitely see that there's a way bigger hole right there. And again, you know, our Slice has never said this, and I really don't know why they redesigned this, but my guess is anybody that's had a mosquito and has had a jam, clearing the jam, these little surgical tubes, which is basically what the heat break's made out of, they are so sensitive, especially when they're hot. You know, trying to push filament jam through there has proven deadly to many of my heat breaks. I've broken several of them, or I've snapped them off at the copper down here. So I assume that this is for kind of a more robust heat break contact patch, etc. And just like that, slid it right down over the top of those 4 posts, little surgical pin posts. You want to make sure that that is in all as best as possible. Let's see if I can show you. I mean, this is really cool. I just noticed this, but it looks to me like you can put a PTF tube right down against that heat break. So that is definitely very, very nice. Whereas on the old one, you had a little bit of a PTF divot right here, but you know what, a millimeter maybe. Yeah, so this is really, really nice to get kind of the PTF tube down in there, and there's some support around it, so pretty nice. All right, so I just stuck the screws down in here either side, and you can see them right here. I reused the old screws. I save all these parts. I have a whole bin back here that is full of Slice Engineering parts. So I try to use as little of the new stuff as I can because, well, I have these on all my printers. I will continue to have all these on all my printers, and so it is always nice to have some spare parts around. So, all right, next up we are going to put a nozzle in here, and we are going to put the heater and the thermistor in here, and then there's a little retainer screw right here. Again, it's really important that you put some thermal paste on the, I don't know that it's so important on the heater. I just put a little tiny itty bitty bit in there, but it is important on the thermistor, as the thermistor is not a perfect fit in here, and the thermal paste basically, you know, creates a bond between the heat block and the thermistor, so you have accurate thermal readings while you're printing. So this is what a complete mosquito looks like when it's finally assembled. And like where I dropped it off, we basically put the 2 screws down through these holes, and then we cinched them up, and hopefully you can kind of see maybe a little better. I don't know. You can see the screws right there. So these screws right here in the middle is what holds this whole assembly together. So those screws, you know, basically connect the heat sink and the heater block together on these little surgical standoffs, the surgical stainless tube standoffs, and that's what makes it really, really rigid. And that allows you to, you know, do the nozzle, because you can twist this all you want and it's not going to move because they're locked into these 4 pins. So anyways, just thought I'd show you kind of a close-up. And that's it. So as you can see, this is it mounted on the printer. What you see here is you see the final product on the printer. The heater is in it, the thermistor is in it, and let's see what else. And it's mounted, right? I mean, it's really not that complicated. You thread the nozzle in, and if it's a used block like we're using today, then you basically should heat it up and do a final tightening on it. But if it's a brand new one, you definitely don't need to. And I only say that because you get filament down inside of it, and you just want to make sure that that nozzle is tight. So anyways, guys, thanks for watching. Project R3D, thank you for the parts. I'm sorry it took so long. Please let me know if you have any questions. Hopefully this kind of explains how they work, why you may or may not want to buy them, and a Mosquito or a Magnum hot end, and how easy they really are to work on. They are extremely easy to work on. Again, they're not cheap, but you know, nothing good is ever cheap. So anyways, thanks a lot. Catch you on the next one. Bye, guys.